Hello guys, welcome back once again. So today our topic of discussion will be about the identities used in trigonometry. Okay, so let's get started with that. Now before we start writing down the derivation of identities, let us first of all consider one triangle, right angle at B and angle A taken into consideration. So with the help of Pythagoras theorem, we can easily mention that AC square is equal to the sum of the square of the two sides. In this case, it is AB square and BC square. Okay, now let this be our equation number 1. Now I'm proceeding ahead and deriving the three important identities of trigonometry. So let's begin the derivation of the first identity, the fundamental one. Dividing each side by AC square. Now we'll be dividing each side of this equation number 1 by AC square. So let's see what happens here, which will be giving you somewhat this kind of equation here. And if you observe here, you will see there's ratios AB by AC and BC by AC, which are basically nothing but the adjacent divided by hypotenuse and opposite divided by hypotenuse, which clearly means that they are nothing but the trigonometric identities cos and sine. So we can mention them here and replace the ratios with the trigonometric identities. And that is our first identity, cos square A plus sine square A is equal to 1. Now this identity is valid for all the angles ranging from 0 degree to 90 degree. Okay, let's see the next one. Now we shall be dividing our equation number 1 by EB square, and when we do that, this kind of situation arises. If you see the ratio once again here, AC divided by AB, which is the reciprocal of cos, because it is hypotenuse divided by adjacent, and AB will cancel out and it will be equal to 1, and this BC divided by AB, BC divided by AB, that is opposite divided by adjacent, means it is 10A, which means that we can mention the identity as in this manner: sec square A is equal to 1 plus 10 square A. So this is your second identity, and this is also valid for all the angles excluding 90 degree, because sec A and tan A are not defined for the angle of measurement 90 degree, which you must be knowing from the table that we had discussed in our previous tutorials. So this was the second identity. Now let's move on to the third identity, and now we shall be dividing our equation by BC square. If you noticed one pattern here, we first of all took AC square into consideration, means divided our entire equation by AC square, then we divided by AB square, and now we are dividing by BC square. So this can be of great help to you in case you want to memorize or you want to learn the derivation. Okay, coming back to the derivation of third identity. So once you divide the equation by BC square, this situation will arise, and AC divided by BC is equal to cos x square A, no need to mention y, and AB by BC is cot. So our third identity is cos x square A is equal to cot square A plus 1, and this identity is valid for all the angles except 0 degree, because these identities cosec and cot are not defined for A is equal to 0. You can check the table of values for that. Okay, so this was the third identity. So you have to remember, memorize these three identities, and of course the derivation and how they are being derived. Okay, let us move on to the question solving now. The first question, I am referring the NCERT book of grade 10, exercise 8.4. I will be discussing here a few important questions, so you can go through this tutorial in case you need help. Okay, beginning with the first question, we have to write down all the other trigonometric ratios in terms of sec A, means there are sine, cos, tan, cot, cosec, all of these ratios we have to mention them or write them in terms of sec A. Okay, it is very simple. Let us begin with the first one, that is the cos A. It is easily mentioned that it is basically the reciprocal of sec A, so we can mention cos A is equal to 1 by sec A. That is it for the first one. Let's proceed ahead and write down now the sin A in terms of sec A. So shall be using the identity sin square A plus cos square A is equal to 1. Why I use that? Because I do not have any direct connection of sine with sec, but I do have the connection of cos with sec. So with the help of this identity, I can reach to sec via this cos A. Okay, let's see how we can do it here. I just made sine A as the subject of formula, so it shall be mentioned in this way, and see, I just replaced or wrote my cos A in terms of sec A. So this will be the scenario, and once we simplify it out, it will be in this manner. So sine A will be plus or minus the square root of sec square A minus 1 divided by sec A. This is how we represented the sine A in terms of sec A. The next one in the line is cosec, and of course it is the simplest form because it is the reciprocal of sine A. So whatever answer we got for sine A, the reciprocal of it will be the answer for cosec A. Very simple to understand. Let's see the next one, that is the tan A. And if you notice here, we already have the identity sec square A is equal to 1 plus tan A. We shall be using that to represent tan in terms of sec. So this is how it is done. And cot will be once again the reciprocal of tan. So we can simply write it down as plus or minus 1 divided by square root of sec square A minus 1. That's it. So this is how we calculated or identified all the identities in terms of sec A. Okay, let's see the next question. It is about evaluation. The ratio is given with sine in the numerator and cos in the denominator. Now it seems to be a bit complicated because we do not know the angles like 63, 27, 17, 73, because what we have done so far is only about the some specific angles, that is 0 degree, 30 degree, 45, 60 and 90. We haven't come across these angles yet. But I think so the angles will not be that much a problem because we know one concept, and that is about the complementary angles. So what I will be doing here, that I will be taking into consideration my identity number 1. I know that sine square A plus cos square A is equal to 1. So if somehow I am able to manage here cos with sine in the numerator and same in the denominator, I shall be able to get my answer very easily. So let's see what we do here. I am taking sine 27 into consideration here, and I am writing that thing down in terms of cos. So with the help of complementary angles concept, we can easily mention that sine 27 is equal to cos 63 degree. Okay. Similarly, if we take into consideration cos 73 and try to write it down in terms of sine using the complementary angles concept, it will be equal to sine 17 degree. So now we will be simply replacing these values in the above equation. So this is what we will get, and as I given you the hint in the very beginning that I tried to convert them in terms of the identity. So this is what we are getting here. The numerator is having sine square plus cos square, denominator is also having sine square plus cos square, but the angles should also be the same. That only then you will be able to equate them equal to 1. So here our angles are also matching. When sine square 63 plus cos square 63, the angles are same. So it will be equal to 1. And similarly, cos square 17 plus sine square 17, again the angles are same. So it is also equal to 1. So this is how the evaluation of the above expression is obtained as equal to 1. Okay, let's see one more question. Now here we have to choose the correct option and we have to justify our choice. Means basically we have to evaluate this as well and identify that out of this A, B, C, D, which of these options are correct. Before I proceed ahead, I would like to discuss one thing with you. Most of you guys must be aware of this fact, but because we haven't discussed this fact so far in our tutorials, let us discuss this now. That we know the formula of sine and cos. That sine is basically represented as opposite side to theta divided by hypotenuse, and cos is about the adjacent side to theta divided by hypotenuse. If we take the ratio of sine by cos, this is what we'll be getting. Okay, upon simplifying, we shall be getting opposite side to theta divided by adjacent side to theta. And if you know, this is equivalent to tan theta. So you can easily say that tan theta can also be represented in terms of sine and cos as a ratio of sine to cos. So this is a very important observation that we have seen, and it will be of great help for you guys to solve the questions that comes ahead where you have to prove that left hand side is equal to right hand side. It might be of great use for you. So please remember this thing, that tan theta can be expressed in terms of sine and cos in this way. Okay, I'm once again coming back to my solution here. So now basically I'm seeing here that the identities are tan, sec, cot and cosec. Uh, Let us try to make them or like converge them into one or two identities max to max, so that we can be able to simplify them more easily. So what I will do, that I will try to convert all these identities in terms of sine and cos. So let's see what we can do here. That, as I said, that tan theta is equivalent to sine divided by cos. So I replace that value with this, and sec is obviously the reciprocal of cos, and cot is reciprocal of tan. So if tan theta is equal to sine divided by cos, so cot will be equal to cos divided by sine, and cosec is once again the reciprocal of sine theta. So now it will be somewhat easier for us to solve them, because now we'll have to observe only two identities. Okay, let us proceed ahead with solution. If we try to solve them and make it simple, this will be the next step. Okay, now here we'll be using the identity a plus b, a minus b is equal to a square minus b square. On what basis? So if you see the numerator here, let us consider that cos theta plus sin theta is our a and 1 is our b, because if you look at them closely, they are somewhat related to this identity, cos theta plus sin theta plus 1, and once again here cos theta plus sin theta minus 1. So if we try to write them down in terms of a square minus b square, this is what we'll be getting, correct? Because cos theta and sin theta are taken as a here. So this is what we'll be getting. Now once again, if we expand them using the identity a plus b whole square, this is what we'll be getting. Okay, if you see here, we are getting this cos square theta plus sin square theta, and that can be equal to 1 once again. So I am replacing this cos square plus sin square with 1. This term I'm writing as it is, and minus 1 we already have, and denominator is unchanged throughout. So let us try to simplify it. The 1 will be eliminated. So we are left with only 2 cos theta sin theta divided by cos theta sin theta. All of them are in multiplication and division. So cos and sin can be cancelled out. So we are left with answer 2, which is our option number C. And this is the justification which we give here, that why option number C is the valid answer for this question. Okay, let us see the next question. Now we have to prove the following identities which will be given here. Basically we have to prove in a few examples here that left hand side will be equal to right hand side. Means certain specific angles, if they meet the criteria, these equations are correct. So let us see that how we can be able to solve these equations. So to begin with, we'll be taking left hand side into consideration first, and it is cosec theta minus cot theta whole square. Let us see what we can do here. First of all, expand them using the identity a minus b whole square. So this is what we'll be getting. Okay. Now I am trying to convert all these identities in terms of sine and cos once again, because if I convert them, the simplification will be much easier for us. So that is what I have done here. Let's see what is the next step here. So it is the simplified version of the middle term, to be specific. Okay, and now we have a common denominator, so we can easily write down the numerator collectively as 1 minus 2 cos theta plus cos square theta divided by sine square theta. Okay, so the numerator is now written as 1 minus cos theta whole square. How this is possible? For that you should know the identity once again. We have used the same identity here, but this time we have used that identity in the reverse form, because what we were having here is this form of identity, a square plus the middle term, in this case it is minus, and the last term square. So our identity used here is a minus b whole square. Sorry guys, I have made a mistake here. It should be a minus 2ab here, so please consider this, and I'm really sorry for this mistake here. Okay, once again coming back to this step, so this is how we obtain the simplified version, and if we solve it ahead, what will happen? Let's see. 1 minus cos theta whole square, and this second thing, the denominator, is once again simplified further using the identity of a square minus b square. So we can write down it as one bracket of 1 plus cos theta, another bracket of 1 minus cos theta. So 1 minus cos theta can be cancelled out because it is existing in the numerator also and denominator also. So what we are left with is 1 minus cos theta in the numerator and 1 plus cos theta in the denominator. And this is what we want for the right hand side. So it is equal to right hand side. Hence it is proved. Okay. So this was it for this question. Let's see the next one. Now here we have to once again prove that this ratio on the left hand side is given is equal to 2 times sec A. Let's see what we can do. First of all, we'll be taking as usual left hand side into consideration. I have already simplified the left hand side here by taking the LCM. So this is what I will be obtaining. Now using the identity once again for this 1 plus sine A whole square. So we will be able to write it down in this way. And again, if you can notice here, cos square A plus sine square A can be written as equal to 1. Okay, let's proceed ahead. Try to simplify them as much as possible. So this is what we'll be getting. I taken out 2 common in the numerator. So this is what I will be getting, and 1 plus sine A will be eliminated. So what I am left with is 2 divided by cos A, which is equal to 2 sec A, because cos A is the reciprocal of sec A, which is equal to right hand side. Very simple to understand. Okay, let's see the next question. Okay, once again the same kind. We have to prove left hand side is equal to right hand side. Let's see. Let's begin with left hand side first. Write down the expression on the left hand side. Okay, I'm converting them in terms of sine and cos, because my answer on the right hand side must be in the form of sec and cosec. So there is a relation of cos with sec and cosec with sine. That's why I am trying to simplify this tan and cot. Sorry, I'm trying to replace tan and cot in terms of sine and cos. I will be simplifying my denominator because it is weird. So it will be in this way and can be written in this way for further simplification. So what we are left with is this: cos sine squared theta divided by this plus cos squared theta divided by this. I think so both the terms are same here except the sign. Sin theta minus cos theta is available here also. The same thing is available here, but actually the terms are interchanging their positions. So I think so we shall be able to take them out common, but for that we have to change this sign. I hope you can be able to figure out that as well. So what I will do is that I will try to make them equal, first of all, the brackets, by changing the sign in the middle. Okay, and then I will be taking it out common. So this is what I will be obtaining. Now once again, once it is taken out as a common, we will be able to simplify this part which is outside the bracket further by taking the LCM. So let's take their LCM, and if you are once again reminded of your identity a cube minus b cube, you will be able to solve this sine cube minus cos cube in this way. So once you get this part, I think so you will be observing this fact as well, that this sine theta minus cos theta here in the denominator can be eliminated with this in the numerator because they both are existing. Okay, so what we are left with is this sine square plus sine cos plus cos square divided by cos theta sine theta. Okay, once again the identity will be taken into consideration, sine square theta plus cos square theta. Let's continue that part here in the next page. Okay, we are here. Now we have to once again identify that this can be written as equal to 1. So this is what I have written here, 1 plus sine theta cos theta divided by the denominator cos theta sine theta. So we can split them further to simplify it in a more better way. So you will be able to identify that this part will be completely eliminated, and this part is eventually written as the reciprocal of cos and sine, and that is equal to what? Sec theta cosec theta plus 1 can be mentioned as in this way also, 1 plus sec theta cosec theta, which is equal to your right hand side. The question is quite lengthy, but it is not that kind of rocket science, so you will be able to solve it with ease. All you need to remember is the identities from your grade 8 or grade 9 maybe. So please brush up your concepts, the fundamentals, because without that it will be difficult for you to attempt these questions. Let's see another question. 1 plus sec a divided by sec a is equal to sine square a divided by 1 minus cos a. They have already given you the hint here that you have to solve LHS and RHS separately, because this is not the case where you start solving the left hand side and eventually you will arrive at the right hand side expression. So we have to solve them separately. As usual, we shall be taking left hand side into consideration here. So let's begin with that, and we will be converting that part into cos, and upon simplification what I will be getting is this cos a eliminated. What I'm left with is cos a plus 1. This is your left hand side. Let us see now right hand side. This is the right hand side part, sine square a divided by 1 minus cos a. Okay, if you are able to identify, I just used this identity and I converted my sine square in terms of cos square by using this identity. Why? Because to I want cos a to be appeared here, because it is already existing in the denominator, and what answer we are expecting for the right hand side is or should be in terms of cos a, because that is what we got for left hand side. That's why we don't need sine square a here anymore. So I converted that part. So all these kind of intuitions should come to you, that what next step we have to take and what identities are needed in the simplification. So please take care of that. Once again, simplifying it using the identity a square minus b square. So your 1 minus cos a in the numerator and denominator will be cancelled out. I think so some students have a problem with cancelling out these identities because they think that minus sign is existing here, so how are we able to eliminate them? I know that the number of students who are expecting these difficulties is less, but I was also among those students, because maths is sometimes complicated if you don't understand the fundamentals. So dear, basically we are considering this entire bracket here. Entire term is considered as a single number. So that is why we are able to eliminate them more easily. Okay. So don't fall into that confusion. And if you still have any doubts with that, you can simply come in touch with us. We will be able to understand. We will be able to make you understand in a more better way. Tutorials has there some limitations, so I will not be able to answer all your queries. You can easily reach us at our email and the other address given in the channel. Okay, once again coming back to the solution. So if we eliminate them, we are left with 1 plus cos A. Hence, LHS is equal to RHS. Okay, this question was very simple, I feel. One more question. Okay, the tutorial will be quite long because the questions of exercise 8.4 are, somewhat lengthy. So we will be doing some more questions. Let's see what this question has for us. We have to once again prove the left hand side equal to right hand side, and this time we have to use the identity cos x square a is equal to 1 plus cos square a that we have done so far. Okay, so let's begin. Once again solving with the left hand side first. Okay, now because they have mentioned here that we have to use the identity cos x square is equal to 1 plus cos square a, I think so we should not continue with this cos and sine which is existing in this left hand side part. So what I will do is I will be trying and divide my numerator and denominator with sine. Okay, because if I do that, what I will be obtaining is cot and cosec upon simplification. I hope you are getting, because that is why I have wrote this thing down in a very explicit manner. I am dividing my sine A in the numerator and denominator separately. To balance the part, we have to do the division in both. We cannot do in one. So that is what we obtain here. Okay. Now we will be using this 1 and we will be writing this one as cos x square minus cot square a, because that is what the question has asked us to do. So it will be written in this way now. Okay, let's see what comes next. Once again we have to use the identity a square minus b square to solve that bracket, which will be equal to this. And this cot a and cosec a can also be written together now, so it will be somewhat of this kind. If you identify this cot plus cosec is appearing here and cot plus cosec is appearing here also, which we can take it out as a common identity here, sorry, common term here. So what is left with the first term is 1 now, and the second term is left with cosec a minus cot a. Okay, once again we are considering these two identities as a single term, that's why I have written them in the bracket, so don't get confused with that. Okay, so what will happen further? Let's see. That cot a plus cosec a is equal to, sorry, one bracket cot a plus cosec a, and another bracket, if we open this bracket here, this cot a sign will change from negative to positive, so eventually it will be getting eliminated with the denominator. So what we are left with is cot a plus cosec a, and that is what we need for the right hand side. Hence it is proved that left hand side is once again equal to right hand side. The questions are somewhat typical, somewhat simple, but ultimately you have to keep your eyes open and identify that what is given on the left hand side and what is required on the right hand side. That will make your work smarter. Let's see the next question. Okay. Once again, proceeding ahead with the left hand side first. Okay. I think so we can take out sine and cos common in the numerator and denominator. Okay. And once we do that, we can still further simplify it using the identity, if you have seen here. Sine square is replaced by it is 1 minus cos square theta, because basically, as I said, we have to keep our eyes open. Cos is existing here, so if in case we try and attempt to make this sine square also in terms of cos, it will be easier for us for further simplification. That's what I did, and eventually I multiplied this 2 inside, so that's what I got here. Okay, if I simplify my numerator bracket, minus 2 plus 1 will be minus 1 plus 2 cos square theta, which is actually matching with this denominator. See, as I said, that only thing I had to do here was to take out the common terms and then writing my numerator in terms of denominator identity. So I actually arrived at the solution here. See, now this will be eliminated once again, so only sine by cos will be left, and that is equal to tan theta. That is equal to right hand side. Very simple. Let's do the next one. Once again, here the hint is given that we have to solve them separately, the left hand side and the right hand side. So let's begin with the left hand side first. Cosec A minus sine A, one bracket, another bracket is sec A minus cos A. Okay, I'm converting once again the identities which I don't like, cosec and sec, in terms of sine and cos. So this is what I will be getting. Simplify it further. This is what you will be getting. Now 1 minus sine square is equal to cos square. So I wrote down here cos square. And 1 minus cos square is equal to sine square. Using the identity, sine square theta plus cos square theta is equal to 1. So you are left with cos A sine A on the left hand side. Let us try and solve the right hand side again. 1 divided by tan A plus cos A. Now remember, see, here is the point at which you have to consider that tan and cot is given. Eventually you want your answer to be matching with the left hand side, and the answer is sine and cos. So that thing should strike in your mind, that you have to basically convert your given identities in terms of sine and cos. That's what I will be doing here, and simplifying my denominator, and more simplifying, because sine square A plus cos square A is equal to 1. Upon simplifying it, we are eventually reaching our destination and finally reached. Hence, left hand side is equal to right hand side. Questions look simple, but your presence of mind can save your day. Let's see another one. Once again, left hand side we shall be taking into consideration. Now here the question is, see if you can see properly, that this expression is equal to this expression is equal to tan square A. So we will be solving this question as, first of all, left hand side and make it equal to tan square A, then right hand side and we'll make it equal to tan square A. Okay, so let us first of all take this left hand side into consideration. 1 plus tan square A divided by 1 plus cot square A. Okay, now because cot square has no use here, eventually we want our answer in terms of 10. So I will be writing my cot square in terms of 10 square, and further simplifying my denominator part, which will be somewhat like this. Upon more simplification, this 1 plus 10 square A will be gone. Hence, left hand side is equal to 10 square A is obtained very easily. Let us park it here. Let us proceed with the right hand side now. 1 minus tan A divided by 1 minus cot A whole square. Once again, cot is not needed, so write the reciprocal of it, that is 10, and simplify it, which will give you this. More simplification, and yes, here the sign will be changing because it is 1 minus tan A, this is tan A minus 1. That is why, to convert this 1 minus tan A in terms of tan A minus 1, we have to change the sign. So we are left with minus tan A whole square, and if we square them, this minus minus will be equal to plus, and tan A square is equal to tan square A. Once again, we got the right hand side equal to 10 square a. Hence, our left hand side is equal to right hand side is equal to 10 square a. Easily obtained. So guys, I think so the chapter gets completed here for the grade 10, not for the high grades, because trigonometry has more questions and more applications which still needs to be understood and discussed. But we shall be restricting our understanding till here only. We shall be meeting again with this chapter once again, but in future. Till then, please stay tuned to our channel, and you can always reach us in case of any queries related to any grades. We are happy to help you for your better learning. All the very best, and please, if you like our video, subscribe it. Thank you very much.